Here we're going to evaluate the integral using integration by parts, and the integral is x squared times the cosine of m times x times dx. Okay, so the first thing we're going to do is we're going to let u equal x squared, and dv is going to equal the cosine of m times x dx. Okay, so now what we're going to do is we're going to go ahead and take the derivative with respect to x. So du is going to equal 2x dx. And then we want to find the antiderivative of the cosine of mx dx. So again, just using what our previous section told us, we want to take the antiderivative of the cosine of mx dx. So if we let u equal mx, then du, the derivative of mx is going to be m dx. Divide both sides by m, so 1 over m du is going to equal dx. So we're going to put in our substitution, so we have the cosine of u times dx, which is 1 over m du. Factor out the constant, which is 1 over m. And therefore we have the cosine of u du. So what is the antiderivative of the cosine of u? Well, the antiderivative of the cosine of u is going to be the sine of u plus c. So we have 1 over m times the sine of mx plus c, and therefore there is our antiderivative. So v is going to equal 1 over m times the sine of mx. Alright, now let's go ahead and rewrite the original problem. So we have the integral of x squared times the cosine of mx dx. And using the integration by parts formula, which is u times v minus the integral v times du. So we know that u is x squared, v is 1 over m times the sine of mx, minus v, which is 1 over m times the sine of mx, du, which is 2x dx. So let's go ahead and then multiply this out. So we end up getting 1 over m times x squared times the sine of mx minus, let's go ahead and factor out our constant. So that's going to be minus, see here, minus 2 over m times the integral of x times the sine of mx dx. Okay, so now what we're going to have to do is we're going to have to take the antiderivative of this. So let's go ahead and do that. So we want to find the antiderivative of m times the sine, or excuse me, x times the sine of mx dx. So we're going to let u, or in this case we can let capital U, equal x, and we would let d capital V is going to equal the sine of mx dx. So therefore du is going to equal 1 dx, and v is going to equal the antiderivative of the sine of mx dx. So remember here, if we want to find the antiderivative of the sine of mx dx, we would let u equal mx du is equal to m dx, and therefore 1 over m du would equal dx. So this would equal the sine of u times 1 over m du. Factor out the constant 1 over m, and then the antiderivative of the sine of u. So what is the antiderivative of the sine of u? Well, that is cosine. So we would have 1 over m times negative cosine of u plus c, which would be negative 1 over m times the cosine of u, which is mx plus c. So therefore, this is what we're going to plug in over here. So this is negative 1 over m times the cosine of mx. So now let's go ahead and then use our integration by parts formula. So this is capital U times capital V minus integral capital V d capital U. So we know that this is x times V, which is negative 1 over m times the cosine of mx minus the integral of negative 1 over m times the cosine of mx times dx. So we have negative 1 over m times x times the cosine of mx. Factor out the negative 1 over m times the minus is plus 1 over m. And then we want to integrate the cosine of mx dx. Well, if you notice that we've already done that up here, which is the cosine of mx, the antiderivative is 1 over m sine mx. So we would get negative 1 over m times x times the cosine of mx plus 1 over m times, again, that's 1 over m times the sine of mx plus c. Now let's distribute that 1 over m, so we get negative 1 over m times x times the cosine of mx plus 1 over m squared times the sine of mx plus c. So now we're going to go ahead and substitute. So let's go ahead and do that. So we have 1 over m x squared times the sine of mx minus 2 over m times what we got up here, which was negative 1 over m times x times the cosine of mx plus 1 over m squared times the sine of mx, and that is plus c. Okay, so now we're going to distribute the negative 2m to all three of these terms. So we have 1 over m x squared times the sine of mx plus 2 over m squared times x times the cosine of mx minus 2 over m cubed times the sine of mx minus 2 over m times c. So we're going to call this C1 because we're going to end up substituting that. So let's go ahead and write our final solution. So we have 1 over m times x squared sine of mx plus 2 over m squared times x times the cosine of mx minus 2 over m cubed times the sine of mx plus c. And that is where c is equal to negative 2 over mc1. And therefore, there is our solution.